Hi everyone, welcome back. This is Gravitation Part 2. In this simulation, we are going to take four objects of different masses, and with respect to the center of mass, how they move, we want to observe it. The yellow one is considered to be the biggest one. Let's take 300 into 10 power 28 kg, and the remaining ones are smaller. The green one is slightly bigger, but blue and purple I'm taking very small objects. Now we are going to study about their motion with respect to the center of mass. So these are the locations we have. Probably we can have a yellow one over here. All right. And then we can start moving them. So velocities also, how are they? We can have velocities not directed towards it, probably in this direction. And the one could be having velocity in this direction. Then this one I can have velocity. So I'll change the direction of velocities also. Probably something like that. Okay. Now with respect to center of mass, I'm going to observe them. All right. And then let's go. Oh, we have a collision immediately. And then we have to see when the next collision happens. Once the collision happened, those two merge together into a single body. Now, oh, they just missed it. Are they going to have a collision again? I don't think so. They've already stabilized their orbits now. So there's no way they're going to collide with each other again. So we got the stabilized orbits. Okay. Now let's go back again to four objects. Another one I'm going to bring in and then run the simulation. Are we going to have collision? You see the paths are going to be pretty complicated. Very interesting. Now you see they're going in very nice way. You can see the precision happening. That continuous movement, sideway movement is called precision. So the yellow one is moving and also the green one is moving. I hope they are not going to collide with each other. This is a very interesting path we have here. Okay, let's go back with four objects again. I think I can take only maximum four objects here. So four objects let us take. So they had given default like this. Let's run the default the motion and see how they move. This is a beautiful movement. With respect to center of mass we are observing. I'm just waiting if we can have any collisions. We can see the precision happening, how the orbits are getting drifted. They're not closed paths. Okay. Sun is also moving with respect to the center of mass of the system. So are they going to have a collision again? We have to see. So I'll wait for them to collide. Let's see if we can have a collision. Oh, this guy had come back again. Yes, very good. 16 years time he had come back. So this is awesome path. Looks like a real solar system, but only three planets and one star. 20 years are up. It's just a miss, you know. So the lighter object will experience maximum precision. The heavier object experiences the least precision. Precision in the sense the path being disturbed. It looks very beautiful. Yeah, we had a collision over there. So that object got stuck with it. Are we going to have any more collisions? Is there a possibility? I don't think so any soon. They will have collisions, but it's going to take a lot of time. It's only 30 years now, 34, 35 years. It's going to take a lot of time for the precision to happen and then to have a collision uh, for the particles. So these kind of simulations can be run just to understand how the motion of the planets around the sun go. Entire solar system is moving around its center of mass, and the center of mass of the solar system is moving in a galaxy. So it's a very interesting observation that we have here. So I'll just play around once again. Probably I'll take different mass here, increase the mass slightly with the same velocity, but mass has been increased slightly. Now let's go and see what would happen. Now the precision will change now. Yes, we got a collision now. We got a collision. Now they are not going to collide with each other. They'll have a nice swirling movement, like a spring-like structure. Of course, 2D. So we are following the center of mass. This is what you observe there, but with respect to center of mass, the motion would be very simple. So with respect to an inertial frame where center of mass is also moving in a straight line path with constant velocity, that's what you had, a very nice, interesting path. But with respect to center of mass, they just keep moving around about center of mass. We can also show the center of mass here. Around that, they both move. So there is no more precision now. The precision happens when you add one more object. The moment you add one more object, the precision, there is a deviation of their paths, and then collision immediately happens there. So anyway, this is the idea I just wanted to show here, how when you have multiple planets moving around a particular heavy object, how their path would be precisioned, in the sense they won't go in a fixed path, they may get drifted. So we may also expect that the earth might collide with and some other planets in the coming future. It hasn't happened so far. Probably about a billion and billion years, it's possible that some other planet might collide with our planet Earth. By that time, I hope we'll be able to look for some other habitable place in the universe. Anyway, with that, I'll close here. Thank you very much for watching. Until next time, goodbye.